Good morning. Welcome to the 4C webinar, today sponsored by FLARE. Our presenter is Craig O'Neill. Craig is here today on the webinar to talk about some really exciting technology developments related to the camera. Craig and FLARE have been a very long time supporter of the conference. I want to express my appreciation for that. FLARE is an elite sponsor, and Craig O'Neill additionally has just always been there for the conference, always lended a hand, always done what he can do to help us, and been a part of that wonderful support that we have been so fortunate to receive by our many sponsors and exhibitors. So without further ado, I'll turn the program over to Craig O'Neill of FLARE.
Thank you, Steve. I appreciate it, and it's been fun and a privilege to be a part of from the LBT all the way to the 4C. In the years of partnership with the organization as the 4C has evolved into what it is today. And you know, we're also proud. I know that you gave some glowing statements for those that were on the call a little bit earlier. You know, and we always you know, appreciate those statements and recognition. Last year we did receive an award from the Global Energy Show, virtually this year, but when the award planning started, it was still intended to be in person, where we were the 2020 Health and Safety Award winner for, in essence, our somewhat of a lifetime of achievements throughout emissions reduction with our technology. And we're really proud of that. Kind of leads me into what we're looking at today. Many on this, I see some familiar names on here, but many on this call may understand and seen what optical gas imaging is. I'm not going to get into the basics of what is an optical gas imaging camera. I do want to talk a little bit about how it relates in LDAR. How does optical gas imaging, you know, fit into the LDAR mold, and what are some new things that FLIR has had out since the last 4C conference that may be able to help you in your LDAR initiatives, or your, you know, your ESG, or just your emissions reduction efforts. What I do want to get over, that there might be some people, again, I don't want to get in too much about what optical gas imaging is, but look at FLIR at a glance, just to kind of give you some numbers. You know, why would you want to consider optical gas imaging for LDAR, and how is it different than the other? And I'll get into that. As Steve mentioned earlier, you know, we have a new product. We have an expanded GF77. The GF77 camera was the one that we gave away last year that was specially engineered for methane and similar gases. We have a second version of that that is a uniquely engineered way to utilize this technology. We have our updated QL320, the FLIR QL320 quantification tablet. And I'm even going to go out on a limb here, technology-wise, and try to do a live demo here. We have a product that we've launched last month called the GIS 320, which is a payload for aerial optical gas imaging evaluation. And then we have some partners out there that are trying to put together a lot of FLIR solutions, both optical gas imaging and other, to make kind of a full oil and gas solution versus just the optical gas imaging focus. For those of you that may not be aware of who we are as FLIR, we are FLIR on the NASDAQ. There's been some interesting news, which you know, I won't address right now, but there's been some interesting news this week on FLIR's organization. You know, we have about a $4.5 billion market cap, headquartered in Arlington as well as outside of Portland. In essence, we're a company that's focusing on sensing solutions, whether that's in a commercial, industrial, or even a governmental operation. We'd like to focus on our actual sensing solutions. And what a lot of people may not know, that over 40% of our revenue comes from non-infrared technologies. So we have a lot broader spectrum of sensing solution technologies than most people are aware of. And our goal, our mission in the long run, is to protect the environment, is to save lives, and to enhance productivity. We call that our sixth sense. And in general, if you were to summarize that, our mission is to save lives and livelihood. And we feel as though the optical gas imaging, or I do personally, feel as though optical gas imaging is the most unique way within FLIR to be able to meet our mission. If you look at optical gas imaging and you look at the other LDAR technologies, obviously you have a sniffer like a TVA that have been out there for years. When we look at optical gas imaging, and if we don't mind, maybe if you could try to drop yourself on mute if you haven't yet. But when we look at other technologies, whether they're ones that have been out there for years since '85, or whether they're newer technologies like a satellite that Steve referenced earlier, or a box that sits next to a site just to kind of sense gas. A lot of these are actually pretty good at the LD part of LDAR. Detecting a leak, finding that there is a leak on a platform or on a well site or in a basin or in an area inside of a 5-foot bubble. A lot of these technologies might be good at that, but the AR side, LDAR, has 4 letters and not 2. And that's where we see optical gas imaging as uniquely appropriate for utilizing the technology in LDAR. You've got to actually find out where that leak is. If your goal is to reduce emissions, you need to know where those emissions are coming from. This is just a snippet or an image that we submitted in the Quad OA regulatory discussion that just highlights how if you happen to have a swirling wind that may move at different times, we know a TVA may actually go 360 degrees, but if that wind is swirling, we actually have examples and imagery of where people have trouble utilizing a technology that doesn't visualize what's happening. Versus wind effects, again, with optical gas imaging, this is super easy to detect that there is a problem, there is an emission, and now you know where to go to fix that. You'll see this video, tracing leaks as a source. As I talk a little bit, you'll see this gentleman look for the leaks that are visibly evident in optical gas imaging. But still, with the wrong technology, it's still challenging for them to actually detect that. According to the EPA, that would be a leak. Now, if you think about a TVA, which is the baseline or the trademark technology since the mid-'80s for Method 21, if you're off, and according to the EPA in an enforcement, a previous enforcement load, if you're off with a TVA, if you're off with a Method 21 technology by 1 centimeter, you will miss approximately 57% of the leaks. Now, this isn't just FLIR blowing smoke or blowing gas. This is actually from the EPA in an enforcement alert letter that they had. That's a huge number with a very, very small distance. Why and where has optical gas imaging gone to? We have been designated, and regulatory wise, FLIR and optical gas imaging is fairly new to the regulatory scene. We're, in 2005, we launched the technology. So reality is that technology-wise, we are still a bit in our infancy for technology. We're just over 15 years old. We haven't had any type of regulatory drive since 2008 when we were in AWP, but with some limitations in having to utilize other technologies. And it wasn't until 2016 when Quad OA defined optical gas imaging, they accepted the newer technologies within emissions mitigation and defined optical gas imaging as the best system for emissions reduction. But what does that mean? It makes our technology, optical gas imaging, is more effective at finding leaks and more efficient in doing it. You can actually get a higher ROI to see the leaks of where you need to go. So again, we're really proud with some of the stuff that we've looked at over the years and we've seen. Not just the regulatory side. We see a lot of organizations, a lot of the people on this call probably work for a company that 5-10 years ago, you didn't have an ESG and emissions metrics, emissions reduction metrics. And we're really proud of the fact to be a central part of the environment and central part of organizations that are trying to do better and have a better emissions reductions goal. If we look at some of the product updates, and look at this, the largest one that we had this last year was the GF77. And what we did is we dramatically expanded that product. That product initially was made and it had a uniquely filtered lens for detection of methane and similar gases. And what in essence we've done is we've doubled the capabilities of that product. The GF77 now, simply by exchanging lenses, you can actually focus on methane and similar gases like sulfur dioxide. And when I say similar gases, what I mean are gases with a similar absorption spectrum. But by simply removing the lens that was engineered for methane and adding one on that was engineered for ethylene, ammonia, SF6, and other similar gases, you can simply have one camera with multiple lenses and dramatically expand the capabilities of optical gas imaging. We also sharpened the pencil a little bit on this product and made a more aggressive MSRP. So where the product was around $40,000 for methane specific, now you can choose which lens you would want for a $30,000 MSRP. So we're really proud of the expansion, if you will, broader detectable GHGs to do this. We also have 6-degree lenses that make it easier for you to look at those DTM locations and to be able to investigate or visualize. Now I'll notice in the middle of the screen there, this is not a regulatory LDAR applications. This is not a camera that meets quad OA specifications that you would use to meet any type of federal, local, or state regulatory, at least at this time. But as we have discussions with various state and federal regulatory entities, we can actually see how much this technology may fit into their vision and their efforts. If you look on this website, very simple, we have a thought leadership website. It's called flare.com/GF77-series. You can find some information on there on the product, but you can also see a quick link to what we call What Gases Can I See? And it's an expanded list of detectable gases with a much easier understanding of which camera would be usable or which camera would be ideal for you to use to see this. You'll notice any gas on here that is a hydrocarbon gas, the GF320, X320, and 620, our legacy cooled technology that would be quad OA approved. All of those are going to have some level of detectability within this. But there is a much broader list of gases with this new uncooled solution, and at different levels. And so we need to understand that just because a gas can be seen with our cooled quad OA approved camera does not necessarily mean that it would be visualized with the uncooled solution. And of the two new gases industrially, ammonia and ethylene are probably the most prevalent. We do visualize, and one of the main reasons for making this camera is that it actually visualizes sulfur hexafluoride, which is a very common gas in the electrical transmission industry. But if we look at ethylene and we look at ammonia as visualized gases, there is ethylene is used in the oil and gas industry immensely, and this camera has a very, very high absorption to ethylene within the filtered window. And then ammonia is a very common product. And again, the new lens that we have for this GF77 called the GF77HR lens, it is going to have a lot of absorption directly in the filtered bandwidth of this new uncooled technology. We've also done some updates to the QL320 since the 4C conference last year. And so some of the things that we've done is we've listened to the end users. Last year, we launched some stuff. We had the very first QL320 that was out years ago with our partnership in Providence Photonics. And Providence came out with a QL320, the original blue one, in 2017. And then last year at the 4C conference, we launched the FLIR QL320 with a complete new user base, concentration measurements, and a lot of new features that we've had. We've taken some feedback even since that launch and added some unique features to utilize this. But what this product is, it is a camera that works only with our cooled system. It will not work with the previously mentioned uncooled GF77. It's only going to work with our legacy cooled technology and allows you to quantify gas emissions from afar. You can do this for DTMs, You can do this with either mass or volumetric emission rates if you're looking for that. But the new feature we launched last year is the ability to use this QL320 to launch in a concentration reading in a parts per million over a meter path length. Again, this can be used in LDAR, just general optical gas imaging of tanks, pneumatics, compressors, valves, thief hatches. But you can also use this. There are some organizations or some federal agencies that do allow the QL320 as their quantification metric device in meeting regulatory demand. There are two ways to use the QL320. We do have our tethered connection that gives you a little bit more immediate feedback, as well as it does give you some expanded features because you're utilizing the tablet in the field. But we also have our Q mode. What that is actually just a mode in the camera. If you have a FLIR camera, we can upgrade your camera to Q mode. It is a mode within the camera that allows you to store the files so that it can be post-processed within the QL320, whether it's in the truck right after that, or whether it's actually in your office in a comfy chair out of the cold weather later that day or at another time. Again, so you can do this both tethered or untethered with our Q mode. Please note that the tripod, no matter how you use the technology, you would need to stabilize the image so that the algorithm could work appropriately. Some of the updated user interface, we've got user data inputs on the left. All of these are going to be standard. They've just put into a new GUI. We've got some masking features that make it a little bit easier. We can have multiple masks. If you're using volumetric or mass readings, you can actually use multiple masks if you have stuff in there that maybe has reflectivity or doesn't have the appropriate delta T. There are various overlays, including the delta T overlay, which does help you understand what part of the image can be quantified. And that would work also in our Q mode feature. Selecting units, again, whether it's metric or whether it's more standard US things, as well as the various quantification units from parts per million meters all the way to volumetric and mass readings. Various modes, and I'll show you some of these as we jump into the QL320 for just a quick run through here in a minute. With the demo mode that I'll utilize, we have our auto and manual sensitivity that does give you the capabilities to adjust this, kind of like your HSM mode within your camera. Your measure and reset buttons, that allows you when you're utilizing the camera tethered, you can easily record this data, measure, and even rerun the file after you change some of the user data parameters. The results, with the previous versions, you had continually changing results. With the new user outlay, when you see the result, you have a firm number on your quantification with using the QL320. And then you can even see some of your dialog box of what's been happening within the QL320 as you're running this. So what I'd like to do, I'm just going to simply show the QL320, and you should hear me on the screen, but you should be able to see the QL320 desktop. So I'm still here in my office, and I just have the QL320. You'll notice the actual overlay looks exactly like it looked just a second ago, with nothing happening. Now, the easiest way to do this, and one thing that's also unique about this, is that you have the capabilities to use this camera very simply and easily as a training device. If I simply touch demo on the bottom right, now I have a variety of different videos that allow me to understand, educate myself, educate others, train, or even just better understand the operation of the QL320. Right now, this video is running in the QL320 through the parts per million, the concentration reading. I'm going to tap measure on the bottom right. Now it's actually running that file. It doesn't do anything until you ask it to measure. So now I'm going to tell this to measure and run that file. When it's done, it will give me an accurate reading of the QL320 output for concentration. And this is approximately a 26,000 parts per million meter leak with the user input data that I have set on the left. Now, if I tap next, you'll notice a lot of the user data will change. in accordance to the way that this previous file was recorded and set up. I can now show you that with something like this, I can change it from, I'm going to go with standard cubic feet per hour, and I can add unique features. Now you'll notice that as you move out of the concentration reading, you have a blue circle instead of a black box. The blue circle is what is actually measuring this, and you'll notice that I have the delta T overlay turned on where you can see the red of that. Maybe I want to actually take that red out of any readings. I can turn a mask on. Let me see if I can add a mask. No. Add the mask and be able to actually exclude. Now this really doesn't matter because this leak isn't moving across an area that has a delta T issue, but there may be scenarios where this leak may be floating across an area where there are potential delta T issues, and you can remove that delta T area that is that would have an error reading within it. The other unique thing is if I go back over to another leak here and look at a concentration reading, I don't have to take the reading. What this is actually reading is the maximum concentration reading within that box. Now, if I notice an image like this, and one of the things we'll talk about here in a minute, you want to remove any foreign objects inside of your QL320. So I'm going to take this box and I'm simply going to make it, and I'm going to exclude the hanging key or tag that is from the key part of the actual controller there. Now, as I go back and hit measure, this is taking the maximum reading inside this box as that leak is moving around. And I will apologize, it is a little bit delayed on the video that I can see on the screen here, but this reading is around a 3,500 parts per million meter leak is the maximum reading within that box. In a unique situation or a leak like this, if I really wanted and I didn't have any issues with hanging tags or delta T's, you could literally take this box and make it the entire screen. And as long as you had no interference, you could make this unit would be able to actually take the maximum concentration reading within that box. And in essence, in a video like this, it would be the maximum concentration reading within the entire screen. Again, there are no foreign objects in this, like a hanging LDAR tag or a key hanging from a controller opening. This would just give you a more accurate, a more unique way to look at this because it's taking the entire screen. And again, all this is, I'm just kind of showing you, we've got about 10 different ways to utilize this in a demo mode, even going in to visualize some thief hatches to be able to see leaks and readings within thief hatches and various other operations. I'm not, due to time, I'm not going to get in and do a more expansive training on this, but we do actually have some training online of previous presentations that we've given on flare.com in our under our training section. So now I'm going to jump back over to make sure we can visualize this. I'm going to jump back over to my desktop here. There are some quick tips and tricks that we can understand a little bit in utilizing this QL320 solution. One is you always need to use a tripod. I've talked a little bit about this, the way the algorithm works right now, and we're working with our partners, Providence Photonics, to try to see what we can do to eliminate this in some ways. But the way that the algorithm works is that the unit does have to be stabilized. You want to ensure, especially if you're looking at volumetric and mass readings, that the center point of the leak, the leaking origin point, is in the middle of your screen. And you also want to ensure that there are no foreign objects, like an LDAR tag or anything like that, hanging from the seam, because what happens is if that is hanging from the seam, the camera and the algorithm within the QL320 would visualize that as potentially being an actual moving pixel or a leak, and that would be would present a dramatic error in your reading. The last thing I want to introduce is the new Thermal by FLIR GIS 320. There's an organization called Workswell that we partner with out of Europe, and they've taken our technology and we work with them, and they've put it in to a plug-and-play gimbalized unit for optical gas imaging with our cooled solution. Again, the inside of this camera, the detector inside here, is the same detector, the same engine, if you will, that we use, and it is actually Quad OA approved. A G300A is the same detector, engine, and everything as a GF320, GFX320, and so we have that built in to this payload that is really drone agnostic. It does work, and there is a direct plug and play that you can use with an M600, which is one of the most popular drone solutions out there. And again, this is a Quad OA compliant solution because the engine inside of it is just utilizing our G300A. Some of the stuff you get with this, and where our partner Workswell has put together a unique thing, is that there's multiple control protocols. And if you go look at Grimsey, it works with just an off-the-shelf Grimsey T3 gimbal. It does have an optical visual camera with a 10x zoom so that you can actually hover over, find a leak, and hopefully even see exactly what's leaking and document that. And it is extremely lightweight. Compared to a lot of drone things, maybe extremely is that. But for an optical gas imaging cooled solution, they've really streamlined this and made this a pretty lightweight solution for a heavy industrial application. And lastly, we have other people out there, and FLIR does have the capacity, and we have the capability of providing sensors to do more than just optical gas imaging. You can combine FLIR needs, combine your needs and applications. As an example, you can use the same general security camera to do tank level inspections. You could put this either on a pan and tilt or even on a fixed mount. There's a company that we're working with in Colorado called CleanConnect.ai, and they're utilizing our cameras, our very off-the-shelf security cameras, to do tank level inspections with percentage. The numbers there is the tank number, and the number on the right is the percentage full that tank would be. Again, of course, you could mount next to this. You could do this in tandem with an optical gas imaging camera to make sure that you can, reduce emissions. Whether it's our new uncooled solution that may not meet regulatory requirements, but would help you meet some of your internal emission metrics in reducing methane emissions. This is a complete solution. We'll work with you, or CleanConnect would work with you. We provide the solution to say, what's wrong? What do you need done? We'll work with the solution and say, here's the plan. Once we find that plan, we have partners that integrate this technology to get the communications, install the systems, and make sure that all the technology, from how it's communicating, how it's powered, to the units itself, are working. And then making sure we execute on the desired need within the camera. Are you looking for optical gas imaging, tank level monitoring, security, all three potentially? Again, utilizing the umbrella underneath FLIR, we have a great technology, and then package all that together in a UVMS so that you can see what's happening. So again, we have some of this technology. We've got partners that have streamlined this and kind of put it together in a nice package as well. If we look at kind of an upstream platform, you could potentially use a radar to detect if somebody was approaching your facility. And at that point in time, you could either do a pan and tilt to confirm, is that a human or a dog or a deer, or what's going on at different areas that radar could detect, or maybe have security or tank level solutions on the outside or in the external of your facility. Of course, you could do a fixed OGI solution to look for leaks at important areas within the facility. And then once you find that, again, that AR piece, whether you're using optical gas imaging, whether you're using a satellite, whether you're using other types of technologies that may not be FLIR based, the optical gas imaging camera is going to be the most critical solution that's out there in the market for the and repair. because you need to know what's leaking, where it's leaking, and where I need to go. And the optical gas imaging solution does give you that unique capability. I tried to keep this right around 30 minutes, and I think I did somewhat okay. And Steve, I don't know if there are any questions that we'd like to kind of get at here and discuss.
Yes, there have been a few questions asked in the chat.
Yeah.
I'm going to.
Okay,
Are the security settings on the left configured manually or set by the system?
Those are going to be configured manually within this. So if you're using either the QL320 or if you're actually using the, you could either use the QL320 tethered in the field, or you're using the camera in Q mode. If you're using the Q mode in camera, you have that capability. You have that capability to actually, or not capability, is a requirement to input those things. The camera and the tablet, neither one of them know what type of leak it is. You need to define that. They don't know what temperature, ambient temperature it is. And again, we're looking at streamlining that. They don't know the distance you are away, or realistically, the main gas within that composition. And so you do have to manually input that. Now, it will automatically input the lens that you're using within the camera, because that's just a binary setting within the camera. But the rest of the stuff you do have to input. Now, the unique thing about that is you can also edit that. You can edit that in you can edit that in the QL320 after you're done with the Q mode. So if you did accidentally record the wrong input data, you can actually fix that when you run the analytics within the QL320 in your Q mode file.
One other question was, how does it calculate the emissions? And I don't want to get too much into the technology, but if there's a brief version of that answer.
Yeah, that's a little bit challenging. There is a unique and proprietary algorithm inside the unit that's calculating those emissions. If you put it in simple, it's looking at pixel intensity, and as that pixel intensity changes and it taking into account the temperature in the background, as the intensity of that pixel changes in correspondent, that's why the camera needs to be still, and corresponding to with the background temperature, we know as that singular pixel changes in temperature, it's changing in its intensity. And in essence, with mass and volumetric, as those pixels begin to move in a unique pattern, that Providence has done a great job of creating a unique algorithm to do this very challenging feat. As those pixels move across a path, in other words, across that blue circle or that boundary, that's where they're able to take into effect the intensity at a pixel level and calculate that as it's moving across a distance.
Do you have a camera that measures both hydrocarbon and CO2 concentration?
No, the ability to measure temperature with a CO2 camera is quite, well, it's pretty much impossible, because there is so much CO2 in our atmosphere at one time. So this is going to be, the quantification solution is going to be for hydrocarbons only.
Someone asked about your email. If you wouldn't mind providing your email address, several people have asked for that.
Yeah, I can, I don't know if there's ability, Todd, to just reply to everybody that attended and to do that. If not, yeah, my email is Craig, CRAIG.O'Neill, ONEILL, at FLIR.com.
Here's another question. Interested in both stationary OGI and airborne UAV-based OGI, and some discussion of what stationary can do versus mobile airborne and the limitations of each.
Yeah, so in essence, our stationary unit, our G300A stationary unit, it's not ruggedized, it's not in a unique housing, it's not really mobile. It's the same camera. Our stationary well, keep in mind, if I'm talking about our G300A, our cooled stationary unit is going to be the exact same engine, if you will, the exact same detector that is in our UAV unit. Now, keep in mind, the UAV unit, because of its packaging and housing and all of that, it's going to be a little bit more expensive, but that doesn't just have to be a UAV. You could put that on a robot. You could put that on the on the hood of your truck if you wanted. It can be in other platforms that need a more robust stationary type of housing, like you would get on a UAV. But we do actually have enclosed. You can put our G300A in an enclosure and have a fixed mount solution. Now, we also have our uncooled solution. Again, that is not quad away compliant. It's not the legacy camera for optical gas imaging that people may be used to. We do have a quad away, the non-quad away compliant GF77A that is more specific with methane in its LR version and ethylene and ammonia in its HR version.
Okay, and Craig, in the interest of time, there are about another 10 to 20 questions.
Okay.
We're going to put those questions in an email. You answer those questions, and we'll send those questions and answers out to everyone that registered for the conference. Wanted to thank you, Craig. Just an amazing presentation, and super exciting developments and advancements in the technology. For the 4C conference, we will have the 4C conference this year live and in person. It will be sometime after the end of the second quarter due to the travel restrictions that are in place in many companies extending through the second quarter. So that'll be sometime in July to August. We'll have an announcement that we'll send out via email. It'll be on our LinkedIn page and on the 4C web page also. This webinar will be available on YouTube, on the 4C YouTube channel. And to the many sponsors, exhibitors, and to the many folks from industry who attended the webinar today, and to all the emails that we've gotten in support of the conference, just want to thank you all very much. It means a lot to us. Just all the support out there. Okay. And
Steve, I may highlight that we do have our podcast next Wednesday on the 4C channel. So if there are potential questions that may need to be asked and you want to hear directly from myself or from you, Steve, that could be a platform, and welcome everybody to join that as well.
Correct. And also mention we have previous podcasts that are available on the website. The podcast that we will conduct next Wednesday will incorporate many of the questions in the chat today into that podcast. And so stay tuned for that podcast. Everyone that registered for this webinar will also receive an email with a link to that podcast. Okay, thank you all very, very much. I am going to stop recording.
Thank you, Steve. Thank you for the opportunity. And anybody else on the call, feel free to reach out to me directly if you'd like. Another easier website to remember, I forgot, if you just go to oilandgas@flare.com, you can reach me.